Hello, welcome back to Building Sustainability. This is podcast number 7. So today's podcast is with B. Rowan. And before we give you a little intro to B. Rowan, we're just going to have a little chat about some of the stuff that's going on here on Heartwind Land. So if you just want to get straight to the interview, skip forward to minute
5. Excellently done.
Yeah, I'm just going to edit that back in.
Not, it won't sound like a completely drop shipped in.
No, of course not. So big exciting news at Heartwind this week is that we've just announced our winter courses. So these are 5-day courses, intensive courses.
Yeah.
With classroom sessions and practical sessions, and just aiming to give people a good understanding of natural building.
Pretty much, if you were the sort of person who wanted to build a house and you couldn't come on one of our wonderful residential courses, then this is exactly the sort of course you want to come on. Give you all the information you need, a bit of a practical hands-on approach. Yeah, it's going to be pretty thorough, pretty intense. 5 days, bosh, information.
Yeah. So these will be happening, one in Lancaster and one in Bristol.
Yeah.
Towards the end of this year, October, November-ish.
Yeah, absolutely. We've got a few details to finalise. But yeah, if you look at the website, you can go and have a look, find some information. And we'll be releasing actual dates and costs and all of that other information as soon as we can.
Yes, along with all the other things we've got to do. So on site at the moment, where are we at? We've got a roof on.
Yeah, as Progress a City.
Well, we sort of had a roof on for the last month.
Did we?
But the metal roofing has finally arrived and is on, and we're watertight.
Yeah.
That's very, very nice. We should start clay plaster tomorrow.
Yeah, looking forward to that.
So that's dead good.
Yeah, there's all sorts of amazing wood fibre details and insulation, and we get some windows later in the week.
Yes, some lovely handcrafted oak windows.
Yeah.
And new this season, air tightness tape.
Air tightness. Thank you, Judith.
Yeah, so if you haven't heard episode number 6, I think.
5.
Was it?
Number 6 is Noel.
Yeah. No, you're right. If you haven't heard that episode, then I recommend you do. I think that's about it for us, isn't it?
Yeah, that's a good enough update.
Yes. So do check out our Heartwind Builds is our Instagram.
Yeah, lovely pictures. Yeah, that's a good one. And then, check out our weekly student blog, which is on our website. Give you a bit of an insight into the student experience and keep you up to date with where we're at. That's going really well.
Yeah, I think anyone building their own home would probably do well to read that as well, because it's sort of highlights all the different steps that get taken, and good info.
Excellent.
So to today's podcast, it is B. Rowan, as we said. So B. Rowan has always been, as long as I've been on the natural building scene, she's been one of the top UK straw bale builders. I think she said she's got 20 years experience.
Yeah, that's about when I first became aware of her.
Yeah.
Yeah.
So, I've always known her as that. And, during this podcast, she released a couple of little interesting nuggets about her former life. But it's really an interesting chat because it's sort of 3 parts. The first very much focuses on Ecococoon, which is a straw panel building system. The second third is about B and about her background. Really, really interesting journey that she's been on to get to where she is. And then the final third is about clay and lime stabilising clay and the work that B has done out in Pakistan and Nepal with disaster relief. Super, super fascinating stuff. It should be noted that this podcast was recorded on our build site in the morning. So there is a bit of background chatter as people get ready in the morning. And then you can hear the faint clinks of the scaffold being erected And there's a bit of wind. But there's also lovely little birdsong and nice things. So hopefully that's not too distracting for you. We'll see you at the end.
Thank you. Bye.
Thank you very much for coming and having a chat with us.
Oh, pleasure, Jeffrey. Real pleasure.
So yes, we met up at CAP last weekend for Earth Building UK and Ireland's Clay Fest, and realised that we were building right next door to one of your clients.
Oh, that's right. That's right. Fantastic.
That's how it sort of...
So I'm sat here now on your building site, which is absolutely beautiful. All your students around. I mean, I'm so excited for your students to get such a brilliant experience of building a house from scratch all the way through. What a brilliant opportunity. And it's right next door, pretty much 20 minutes drive, hours cycle.
Yep.
To a very large Ecococoon straw panel house, which is stunning and just another way of working with straw to the way in which your students are going to be working.
Yes.
So they're working with the traditional two-string straw bale technique, and which is what I've worked with for over 20 years. I love it. It's so appropriate for many situations. But today, we've got this climate catastrophe going on that we're all super aware of. And, on our little island alone, we have a carbon reduction quota, which we're not going anywhere near. We have a housing crisis, we have lack of affordable housing, etc. And two-string bales, although I'm totally in love with them still, all these years on, will not change mainstream construction practices. It's not going to make it. So panels are a potential way in there.
Yes, the two-string is sort of ideal for self-builders, maybe one at a time. But as soon as you're talking volume and...
That's right. So prefabricated in factory, with straw, with such a sustainable material, annually renewable, etc. Great thermal efficiency properties, etc., etc. These, I actually believe, can decarbonize construction at scale. We can meet all the requirements in this small island, definitely. For instance, we produce, these are government figures, 24 million tonnes of surplus straw every year, after burning, after carrots, after mushrooms, after digging back a certain quota.
Yeah.
That's a huge amount. And many years ago, we calculated we could be building close to 500,000 straw bale, 2-story, 3-bed houses.
Super efficient, super healthy.
Unbelievable. Now, you just kind of translate that into prefabricated panels built in factory. Having a ready store of these they can go up so quickly. This huge it's about 230 square metre house that we had a look at yesterday, 2-story, that went up in 2 days.
So it's 2 days.
A small crew.
Yeah.
3 of us with a crane and a crane driver and a slinger. And that was it.
That's fantastic.
Absolutely phenomenal. So even with our weather constraints for natural materials on this island, that's very, very doable.
Oh, yes. And the panel thing is something I'm seeing a lot of now in conventional construction. So just by my workshop in Bristol, at the end of the road, they're building some student houses, and it was all prefabricated panels. I would dread to think what was in them, but the speed at which they built just a little housing estate was pretty almost frightening.
Well, that's the thing, isn't it? Our construction industry, they're trained. We are trained to be modular to some extent. Everything is certain sizes, everything slots together, and that's speed, efficiency, money. That's what people work with. So having to develop a relationship with a natural material the way that we do on self-build sites, with a 2-string bale, they're all different to each other, with the clay plasters, etc. That doesn't fit. It doesn't fit the modern construction time is money.
Yes.
Bag of something off the shelf, add this much water, bang.
Yeah, same
done.
every
you don't
time.
have to think. It's same. That's right. This is what we have to do with natural materials. We have to make them fit that kind of model to some extent. And the modular system of straw is very, very exciting. So although we are, as an island, producing more different options, I suppose, of prefab panels and SIPs, the thing about the straw is we're still utilising all those fantastic properties of straw. We are locking up carbon. We are sequestering that carbon. We are not producing a higher carbon footprint through insulating our panels with something manufactured that will kick out pollution and a high carbon footprint. I mean, currently, conventional building houses, they actually create 50 tons of irrecoverable carbon kicked out into the atmosphere. That's an average. That's absolutely unsustainable. You just translate that into a straw house, and we are sequestering that. Instead, we have a better than carbon zero footprint. This is stunning. For the lifetime of that building, we're capturing all of that in the walls of the building, and at the same time, those walls are offering fantastic thermal efficiency and a healthy internal environment for the life of that building. So these panel buildings or straw bale buildings, it's not just an investment, in terms of thermal efficiency over the lifetime of the building, because as energy costs go up, we keep our load low in those buildings, but it's also an investment in health. These are really healthy houses, and I love that. So I don't just want to see affordable housing develop on this planet. I want to see healthy affordable housing. And of materials that will not increase the carbon footprint and environmental burden that our construction industry is currently responsible for. It's a solution. I call these panel buildings, but not just a great option for construction at scale, but also for what I call the uber busy self-builder. Because there's very little traditional self-builders around these days, because of
actual people that pick up the tools and build
a house themselves, because you need time and resources. And we've shifted very much into very time conscious, busy world. Very few people now have the luxury of that quantity of time and maybe access to a whole community of people that actually want to roll up their sleeves and help them.
Yes.
We've lost touch with how we used to build. We're not communities really anymore. And traditionally, the whole community would muck in together and help each other build a house.
That's interesting. So one of our neighbours who supplies us with eggs came over to visit the site yesterday and saw everyone running around with wheelbarrows, and there was a lot of effort happening. He said, this is how you used to build houses.
Yes.
That's it.
Absolutely.
We're putting in the effort. We're not substituting effort for high energy materials and the quick and easy ultra produced.
Absolutely. And now we just give it away. We give that knowledge, that power, that experience, all of it, that collective energy away to professionals, to builders, to to the construction industry, and we're totally divorced from it. So we have a very different relationship with our house. When we're involved in the building of that house, the creation of something, it's a very different relationship. And when we do it collectively, we're building strength in that community. We're building relationship. And sadly, so much these days is so unsustainable. We do so little together. We don't even eat together anymore.
No. Or if we do, we're on our individual phones.
Exactly, with our takeaway pizza on our lap. I mean, we're sort of losing touch with that very important human ingredient in life, which is all about community, connection with each other and also with ourselves. And I think working with natural materials brings us back into that relationship. Yeah.
So these panels that were made, that you've used to create this house in Suffolk, they are from Ecococoon.
Yep.
Am I saying that right?
You are.
I've never been sure how to pronounce it.
Yes, it's the Lithuanian for Ecococoon. It's a panel system created by a very small company in Lithuania, and in my opinion, these are the best panels.
Yep.
Best prefabricated panels I've ever come across.
So there's quite a few people creating these straw-based panels.
Yeah. I think Ecococoon are one of the pioneers, or the pioneer really, of straw panels, and they're fully tested.
Yeah.
They are certificated, kind of up to the hilt and beyond, and they're very beautiful and very efficient. The company has a lot of experience now, many hundreds of houses across Europe. There's minimal materials.
Yep.
Right. So there's minimal timber, although they're all structurally certificated. It's effectively, just timber in the corners. So minimal thermal bridging, and then ply, top and bottom. And in the larger panels, there'll be some reinforcement in between. The straw is from round bales.
Okay, so from the
those are
large
opened
round
up,
bales.
That's right. And then in factory, this straw is then compressed within the panels and trimmed. They're very beautiful. They're only 400 wide.
So they're quite manageable then.
It's wonderfully manageable. 2 people can actually manipulate these relatively easily, although we would use machinery on site for health and safety and efficiency.
Yep.
So the one you saw yesterday with your students, this was we had one crane. These are all craned into position very quickly. And Ecococoon, they use this wonderful color coding system. Everything is color coded and numbered, and it's like a 3D jigsaw.
Yeah.
It goes together so incredibly easily. I would suggest really any carpenters would be able to put a house together very quickly.
Right.
We would come in and train any group who wants to do this. I just I can't get over how quickly that went up. I just can't get over it. It just fills me with joy. I've had 20 years of having to protect natural materials from our weather, and this went up so fast.
Yeah.
I'm still smiling when I talk about it. So it's definitely got a future. It's really, I can see it. Go together for schools, for housing associations, for uber busy self builders, as I say. Ecococoon. One of the reasons I love them as well is their ethos and how they work in the world. So they've created teams across Europe. So in pretty much every European country, there are a team promoting and building with these particular Ecococoon panels.
Right.
These are not teams built of commercial business people invited. These all come from grassroots straw bale builders with many years' experience of working with straw who are only promoting these panels because they are so convinced of the integrity of the panels.
Yeah.
They're really stunning. They really work. You can very easily get passive certification of their system, which is a very interesting system. It's airtight, etc., all the usual passive requirements, by adding 6 centimetres of wood fibre board on the exterior, which can then be rendered. We built up a system that's BBA approved in the UK.
Okay.
So that the whole
it's a lime render, presumably.
It is a lime render, that's right. And then finished with a potassium silicate-based paint.
Okay.
So these are all BBA approved so that the passive certified guarantee that Ecococoon provide for that build-up system is continued with our own preference for lime finishes in this country.
And could it be clad as well?
Absolutely, absolutely. Yeah,
So
beautiful.
Excellent.
Yeah, so it's so far. I think there's only 3 in the UK.
Okay,
but
so
watch
beginning.
this space.
And how many are there around Europe? You said it's
several hundred. Several hundred.
Okay.
I mean, for instance, Scandinavia has just gone absolutely, crazy for these buildings in the last few years. And by that, I mean this is a cold climate. Scandinavia's more cold climate, obviously, than we are, and they have major issues with black toxic mold growth, because of plastic sealed houses, not breathing, all that usual health hazard of sealed housing. So, interestingly, the Ecococoon panels there are sold and promoted for healthy housing.
Really?
The word straw is not even used.
Hang on, I'm just going to send my cat away.
Here comes the building site.
Yeah, she's
super friendly.
She's normally on site supervising people's work.
Right.
So, I guess one thing that people might be a little confused about is this idea of, so we're importing straw from Lithuania.
Yeah.
I mean, that goes against all this excess straw in the
Absolutely,
UK.
absolutely. Good point, Jeffrey. Absolutely. So, with all this excess straw, why would we think about importing straw from Lithuania? Quite right. You know, all our commitment to local natural materials. Lithuania is not exactly local. However, as I said earlier, you know, these panels are the best I've come across, and I'm really happy to honour all the work that Ecococoon have put into this. I love being part of a European team who work together, support each other in promoting straw generally, and these panels in particular. That's a very powerful model, you know, and I think the company deserve this support.
Yeah.
They in turn are really happy to support any country in developing our own in-country panels through
Right.
developing factories here. Once we establish proven evidence base of developing that market effectively. So at the moment, as I say, we've got about 3 panel buildings in the UK, straw panel Ecococoon buildings in the UK. And once we build it up a bit more, Ecococoon are happy to step in and help with developing factories here.
Great. What sort of number is that? Is there a, you know, if we hit 10 a year, then they're interested, or is it a sort of quoted figure?
Definitely the conversation could begin at that point.
Right.
Certainly. I would say we're looking at another 2 to 3 years, really. I'm already in conversation with universities
Yep.
about developing semi-automated systems to help panel production.
Yep.
At the moment, the panels are really affordable, and a lot of that affordability is based on the lower labour cost in Lithuania compared to the UK. So if the manufacturing method currently used in Lithuania were to be used here, that would increase the panel cost, and I'm really committed to keeping that cost down and as affordable as possible, so that we can try and achieve this this carbon reduction construction method at scale. And that's the way, you know, just to keep the costs down and promote it that way. So we already have the technology in timber cutting. We already have agricultural presses. We already have, you know, we need to bring those together, those systems together in factory over here, just to keep those costs down.
Great.
We have enough straw. And that's just wheat, you know.
Yeah.
That's not even the figures for barley and oats and others.
And then what is the cost for these panels? Is there a per metre?
Yeah. Yes, currently, obviously, we are now talking pre-Brexit.
Okay, so it all could change.
Who knows what import duties might be slapped on them. So at the moment, that's €150 per square metre of wall surface area. That's after minusing all the apertures, all the openings. So you deduct the surface area of windows and doors.
Okay.
So we're literally just talking the wall area. So that's actually incredibly affordable.
Yeah.
Now you do like for like with other passive systems, and you're even with a passive build-up, the costs are incredibly competitive.
Yeah. So is there an approximate floor area? Because we generally deal in floor area, don't we, in terms of cost per square metre?
So you mean you mean comparative costings for different building types?
Yeah. So when people ask us, can you build us a house? You know, what's your cost per square metre? Is their question.
Right.
Is
That's
there
always a tricky one, isn't it?
Yeah,
How long
it
a piece of
is.
String, etc.
Do you want the shiny finish, or do you want the rustic?
Yeah. So if it was like for like, shall we say?
Yeah.
You know, everything's got your B&Q fittings or your 5-star fittings, whatever. You know, but like for like, in the UK currently, if you're going to go cheapest chips, poorest performance, probably minimal insulation, etc., you can probably still build for, this is to finish, in the region of about 800 to 900 per square metre of floor surface area finished. So let's say 100 square metre house, you're looking possibly, you could, you know, around about the 800 to 900 per square metre, upwards.
Yeah, no upper
average,
figure.
not at all. The average is in the region perhaps of somewhere 12 to 1500 and upwards.
Yeah.
And the Ecococoon panels are coming in at 1200.
So that's finished.
So that's the finished figure. That's right. You know, that's
So
your
it's after
turnkey
plaster.
walk-in. You know, as a comparable to other building materials and methods. So for a passive, you know, that's incredible. That's really cheap.
That's really cheap.
And it's not only, you know, passive to passive. This is healthy passive. This is breathable passive. This is really sustainable materials passive. This is commitment to the environment passive.
Yeah, there's a lot. I think one of the biggest dislikes of passive houses is, generally speaking, not always, but generally, they're concrete with polystyrene insulation, and lots and lots of polystyrene insulation. So for this to come out as an affordable option of natural, healthy,
high performing,
it's fantastic, and hit that passive house standard, for air tightness and for
easily. Yeah, it's a really remarkable system, and the speed of build, as I say, fills me with joy.
we tried to do a little calculation last night of the house we went to yesterday, 200 square meter, 2-story. We were trying to work out if we were building it conventionally, sort of, stick frame and straw bale infill, how long would it take? And it was sort of, I think, around the sort of 10 to 16 week mark was put on it. So the cost of the panels is very much paid for in labour and.
Yeah, they're a product. It's not like going to the field and picking up your 2-string bale and then working with that straw individually, each bale to build a house together. I mean, which I love. It's a model I love. But this is even though you're paying for a product, the time you save in the installation of your walls is incredible.
Yeah.
So I'd say it's kind of like for like in cost, actually, even though straw is considered to be the cheapest form of natural building. As you know, it takes resources, it takes time, it takes people. And if you're on anything other than a self-build site, those people need paying.
Yeah.
So for 2 days with a small crew, very small crew, I think the figures are in the region of two of us can install 100 square metres of wall area in a day.
That's fantastic.
Now, I would say it's actually now faster than that.
Yeah.
In Ukraine, but that's really fantastic.
So that means that you can move into your house 3 months sooner.
Well, that's right. I mean, we have a relationship with another company, a UK company, that makes roofing cassettes in factory, passive certificated, weather protected. So with the same crane that we'd use to install the walls, in half a day we'd get the roof on weather protected. So really you would have a weather protected shell within a matter of days.
That's incredible.
These panels, which still tick all the fantastic properties of using straw as your primary material.
Wonderful.
Yeah.
It really is. Yeah. Well, it's something that we as Hartwin have been, on the cusp of, sort of exploring different options a little bit. Yeah. So I'm sure I'm going to pick your brains a lot more about this.
Yeah, and add an element, a dimension of Ecococoon panels to it. For sure. Have experience how incredibly straightforward they are to work with.
Yeah.
And their particular system of supply, this colour coding, I mean, everything is just so beautifully smooth.
Yeah.
The whole process.
You showed a slideshow yesterday of them going in, and it was, very, very beautiful to watch.
Very inspiring.
Yeah.
I think so. After 20 years of battling with tarpaulins, etc., speed of build is something that we should embrace on this island for all natural materials, I think.
Excellent. So, I wanted to talk a little bit about your background, if we may. So I've always known you as a straw builder from Amazon Nails and Straw Build. But just last week at Clayfest, you introduced yourself. You started off as an engineer. Is that right?
No.
Did I?
No, it's all right. I didn't start off as that. I did become. Yeah. So
right.
I'm not. Interestingly, I do put myself forward in introductory groups I'm working with as I'm not formally trained in construction, and that surprises a lot of people. And as you know, on natural building sites, there's a lot of women. Today, here we are, 2019. There's still only 1% of women on the trades in construction, which is that was the same figure back in the 1980s when I first started in engineering.
Yeah,
quite shocking. quite shocking. I still hardly believe that has hardly changed. The professional level has changed. There's a lot more women in architectural level and engineering level, but on the tools, it's only 1%. But on a natural building site, is what, 50% or more? I don't know how many, what your percentage is on this site.
We make it 50.
You do? That's your policy?
Yeah.
Okay.
But it's actually, interestingly, it's usually harder to fill the male spots than it is the female.
Right.
We're slightly oversubscribed
Right.
on the females.
So there's always this conversation, why are women drawn to natural building? There's a lot of reasons, a lot of really good reasons, and I won't go into them. We can have a different conversation about that. And we always thought in Amazon Nails, one of the many was we were role models, as women. And so I enjoy saying to women, look, I haven't had construction formal education. And yet, look, this is, if I can do this, you can do this. So I do enjoy that. My background, however, many years ago was pottery. I do some ceramics, which I'm still very drawn to. And, to some extent, creating a vessel and then creating or sculpting a house, it's very similar and yet very different because you're doing it with a bunch of people. And so that really, I just loved that very easy connection with creating and sculpting. And my background, I ended up in Africa for a year when I was 19, and I came in close contact with rondavels, crawls and rondavels. This is the traditional round, effectively wattle and daub houses and thatched roofs, and I loved them. I just loved the sensation, the very different feeling of being on an earthen floor in an earthen building, and that's always stayed with me. I think my background generally, I did peace studies at Bradford University. Many, many, many years ago, very early days of, and within that became very involved in women's politics. Set up Women's Centre and Rape Crisis and Women's Health Group. So my whole background has been very much involved in collectives and cooperatives. I've always worked in collectives and co-ops. Very committed to that way of working. And for various reasons, I ended up in a legal practice and trained in law. That was the last legal co-op in the country, in Leeds, and I was there for a number of years. So when I came across straw bale building, it kind of brought together everything I was really interested in, which was the fun, collective sculpting, shaping of something, the equality base, because this law practice I was involved in, we practiced equality, we had parity of decision making and pay, and we were politically very committed to those who did not have voice. This was like people who didn't have a voice in building and construction or shelter to actually come together and learn skills that really, like myself, we didn't have access to. But prior to going into law, I had trained as an engineer in auto engineering. So I'd been through that whole process of training as the only woman. So I was well aware of what's called a hostile environment. And blokes who are trained in that environment continue training in that environment. We didn't even have a women's toilet when I was first training.
Goodness.
It's really... So I kind of know the situation firsthand for women in a construction. So I know how difficult it is or can be on a predominantly male building site in this country. It's changing slowly, but not fast enough. It's an entirely different world in the natural building world.
So did you actually work as an auto mechanic? Auto mechanic, is that the right term? Engineer?
Auto engineer, mechanic. Yes, definitely. I worked in Sheffield. We had a women's garage called Gwenda's Garage, and it was named after Gwenda Stewart, racing driver in the 20s. And there was a bunch of women. It was really fantastic fun, really great. And we found, a lot of women felt very patronised going to conventional garages. And we didn't just have a load of women come to us, we had a load of guys come as well. We were very successful. And we tried setting up a similar one in Bradford. Because I was living in Bradford. I didn't particularly want to move to Sheffield. There was a lot of back and forth. Ended up working for Bradford College and training different groups of people, training women, training unemployed, different bodies of people in car mechanics, and then MOT tester in Keighley and Silsden, worked in a mainstream garage there at the same time as I was teaching. So yeah, quite a lot of practice. I got the scars to prove it.
Yeah.
And it was challenging, but I think I just loved the learning.
Yeah.
I'll tell you how I started, actually. It was in the 80s with positive action courses for people, minorities in traditional skills. So there might be funding for men to learn hairdressing,
right?
Funding for women to learn how to change your oil in your car, which is what I did. I knew nothing about engines. I went to an evening class for 6 weeks for women.
Yeah.
Look, I would never have gone to a mainstream class. I felt so, I didn't even know how to pick up, a ratchet set. So this was incredible in that I just had a light bulb moment. This fantastic guy, Arthur Lewin, he believed anybody could do this, including women, and I just
must have been pretty...
suddenly saw how an engine worked. It was so exciting. So that was my beginnings, just realizing that even though I hadn't been taught that I could do this, totally not. Absolutely not. My background did not encourage that at all. I had no role models. I just got so excited, and that took me along that path. Now, the same thing happens in construction.
Yeah.
We're so not taught as women, I can only speak as a woman here, but to believe we can do this, it's not in our education. So the excitement to suddenly start to understand how a building is put together, the impact of our materials choices, not just for the life of that building and the health of us within that building, but on the environment. The fact that we can actually, as part of that construction process, be part of something called a solution.
Yeah.
Not just environmentally, but everything I've been talking about in terms of community, reconnection with each other, with our choices, with ourselves, is very, very powerful. It's very exciting. And I just love that whole cauldron of possibility.
And so how did you get into straw? Where did that come from?
Yeah. How does one go from a mechanic through a law training into straw bale building? Good question. So there I was in my little boring grey suit with my little briefcase, commuting between Leeds, and by then I was in Todmorden, back and forth. And we'd had a lot of political changes in terms of legal aid and availability of legal aid. So our law firm was actually really affected, and we were working longer and longer hours to try and sustain ourselves. And it got to the point really with something called block contracting and franchising system, which favoured the big boys, the really big boys. We were a small co-op, and decided eventually to pull the plug. And around about that time, I went to a talk by Barbara Jones, who I ended up working with in Todmorden Town Hall. She'd just come back from Winston Churchill Fellowship trip in the States to research straw bale building. And that was it, really. That was my light bulb moment. It was one of those, I just saw, some people, all we have to do is see this stuff, right? I wasn't even touching it. These were pictures. And I had that light bulb moment. It just ticked all those boxes I already talked about. I could see the creativity, the fun, the community, the connection, the environmental,
getting your hands on clay again.
And the clay plastic. Absolutely, that's the sculpting.
Yeah.
The whole, and doing it together with a group of people. I just went, oh wow, So from there on, actually this is before we decided to pull the plug, but from there on I got very involved in supporting the whole kind of straw movement, which is very young in the UK. There we set up a Bailing Out, which was the first newsletter, supporting straw party to setting up the first association, actually.
SBBA
Wise, Wales, Irish, Scotland and England, a long time ago.
I took on the challenge of that one to create SBUK.
You did.
Many years later.
Good luck.
Yeah.
We've been there. No, that's so very, very early days in the UK. And for me, it was it's a skills transition, if you like, from mechanics into construction. Yeah, and that's through working with Amazon Els. And all my experience was on site, So I learned literally on the job, so to speak, and then moved. I already had experience of training others in mechanics, so moving into training what I was learning. You know, it's a very fast, steep curve. When we finished at the law firm, that was 2000.
Yeah.
January 2000. I was 40 that year. People say life begins at 40, and at that point, although I'd already had about 5 years of my holidays and my downtime doing site work and learning, I went straight from finishing that law job to working in Mongolia on a very large health clinic, small hospital in the middle of this incredible country for Raleigh International, and which is a relationship between the Mongolian government, poverty alleviation program, and energy efficiency program. And the UNDP at the end of that, well, it was for the UNDP as well. They did research and figured they discovered that this was 80% more efficient than any other building in methodology in
80%.
Yeah, absolutely.
Crikey.
Yeah. And of course, Mongolia is extreme climate, super cold in the winters and extremely hot summers. So it's perfect material for that. So I found myself stood on the steps in Mongolia, not in my boring little grey suit, and waiting for a train that just didn't arrive. Those days. Instead, looking out, I called it the edge of the world. It was incredible. And it's like, wow, here I am, 40. Life really does change at 40. This is absolutely astonishing and beautiful. And we slaked our own lime. And, it was a really great community experience. And the whole community involved. It's really wonderful. So, that was my first real experience of full community engagement and real use, real function. This offered something fabulous for the community who even in Mongolia were suffering. All that open skies were suffering from health problems, from burning very high sulfur coal.
Oh wow!
To keep warm. It's very very noxious. Same in China. I've been lucky enough to see the work of Kelly Lerner in China, where instead of burning coal, very very toxic coal daily to keep warm in extreme northeastern China temperatures, they're just burning some agricultural waste once every 2 weeks just to keep the temperature. And it's just what this offers, this technology is just what we're doing with straw. Yeah. Is just phenomenal. It's phenomenal. We're working with effectively a waste material, that offers so much. And I noticed that you had Judith Thornton talking earlier on the blog.
Yeah, she'd be very upset to hear you call it a waste material.
Well, we're not allowed to. It's a co-product, it's a byproduct, etc. But in many countries, it is considered a waste material. It is still burnt. There's the awareness of this as a building material is not yet there. It still happens. I'm with Judith. It is definitely not a waste material. This is a real building product. But I worked with Judith on the Miscanthus build.
Oh, excellent. Yeah, if people haven't listened to that podcast, they should go and
definitely. That's really interesting because that's a different kind of fibre, really, and that's very interesting, Miscanthus. So we tested that because I work on the CAT short courses. So we tested that the previous year as a building material, assessed it really, and then used it in Steph Robinson's house last year. And it's I'm really interested in all the research that Judith's going to be conducting on it.
But it worked, didn't it?
It definitely worked. It definitely worked. I do truly believe that whatever straw you have available, use it. Whatever you've got local to you, you can use. You've got the properties of hollow stem for insulation, as long as it's dried. You keep the seed heads out. This could even be local grasses, perennial grasses that might have no other use. It's something you can bale. That will perform. I mean, really, I was talking yesterday with Lil about, she has 36 fleeces. She doesn't want to, people burn fleeces. Or they leave them to rot in a pile. Bale them. Build with baled fleeces, What have we got locally? What can we use what will offer us? The thermal performance we want, the durability, the structural strength,
I saw a fascinating talk, I think it was at one of the Earth Building conferences, and it was a chap who was trying to make plaster, a natural plaster, from his local ingredients. And he started at 5 metres, and he sort of scratched around, didn't really have any clay, didn't have any sand, the first thing he put on the wall fell off. So he went to 50 metres, And within that
50 meters of what?
50, so as a sort of from his house. So,
right.
drawing a circle on a map.
Trying different soil.
Yeah, trying different soil, but also finding out
and
what
different
it
depths. You need to try out different depths of subsoil. Really.
One of the interesting things he found was that at 50 meters, there was a Starbucks who were chucking away coffee grounds.
Oh, yeah.
So he went in there and suddenly he had
great.
this great aggregate that was well graded, and suddenly at 50 meters he was able to make a working plaster, and at a sort of 100 meters he got to something a bit better and a bit better. It was really fascinating to see how localized he was looking and what he would consider as a usable
Absolutely
material.
Beautiful. This is how everybody worked. What was on their doorstep? What was around them?
Yeah.
Or what was around us? Yeah, absolutely brilliant. I love it. That's the challenge, isn't it? Maybe that's one of your courses. Maybe that's one of your builds you can do. It's like set the students right. Okay.
Sort of a foraging
work within
building.
Work within a radius. Somebody, I can't remember who it was, Gandhi, I think, did say, well, what is the definition of local? And I think he defined it as 7 miles or 7 kilometres.
Right.
7 miles. Why I don't know why, he picked on that. You don't have to record this bit, but that is really interesting. So you could set that as one of your tasks, couldn't it? To research what materials are available locally. It's harder and harder, I think, unless in this part of the world. But still, what is local? We can learn so much from vernacular building traditions. You just look at houses pre-cement.
Yeah.
Look at their foundation systems. Ask old builders, what are foundations you come across in this area, wherever you're building, before cement? And you'll invariably hear that they're very simple.
Yeah.
People knew how to build. They knew how to build on their particular ground, in their particular climate, location. We can look, we can learn. Those that are still standing, they have something to tell us. They really do. Now, obviously, we have the benefit now. We can actually increase their thermal performance, absolutely. But what about their durability? Pre-cement, what's going on there? And lime, of course, is a major. That was our major building material. And this was passed down generation to generation. Everybody would have their lime pits, store their lime putty as their major binder for all building materials. So obviously, as you know, straw bale builders, we've used that wonderful relationship with lime.
Yeah.
External renders, lime-based, and then internal clay plasters. And these days, I'm loving bringing together this relationship between the two materials, lime and clay, for various uses.
Yeah. So you've been using this abroad, the lime and clay combining.
Yeah. So it started in 2012.
Okay.
When post-flood in Pakistan, so 2010, 11, 12, saw absolutely biblical levels of flooding.
Right.
Really extraordinary stuff we can hardly imagine here.
Yeah.
Over that period of time, 30 million people were affected. 30
Crikey.
million people. We can't even conceive of that. That's half the population of the UK. It's absolutely extraordinary. And this is just in southern Pakistan,
Right.
the province of Sindh. Earth building is the predominant building method and material. Millions of earth building houses. It stood for really a long time. Why wouldn't they? Earth is a fantastic building material, but it's not designed to stand in standing water in flood.
Right. So
And a
these
lot of
houses were collapsing.
Well, a lot of this flood water would be standing for, if not weeks, months.
Crikey.
Some a foot high, some 3 foot, some 4 foot, some 8 foot high. Buildings will dissolve. Earth buildings will dissolve, and they did. So this left people, I have to say, who were extremely poor to start with.
Yeah.
Seriously impacted. It was a situation of just desperation, and it recurred again and again, and it is unfortunately likely to occur again.
Because of climate.
Sindh is currently 7th. It's the 7th most vulnerable country to climate change.
Crikey.
For lots of reasons. But we all know that flooding is one of the results of this climate catastrophe that we're all responsible for, and it's happening more and more. Its prevalence is seen everywhere.
Yeah.
And in those areas where earth building is the traditional method, they're very, very vulnerable to flood, and it's usually the poorest people who are going to be affected first.
Yes.
what I call magic mud, what I've come to call magic mud, is if the right proportion of lime is added to a clay content soil, one can stabilise that soil against dissolving in water.
Okay, so you're saying stabilising means that it's no
stabilise
longer...
against dissolving in water,
Yeah.
which is actually so exciting. It's so exciting. Because we're still now in that realm of local, natural, affordable materials. Now, Sind does produce a lot of lime. It's actually used for the sugar industry.
Sugar?
But to be honest, limestone is the 7th most common material on the planet. So it's available pretty much anywhere. And those of who know a little bit about lime, there's a difference in strengths of lime in terms of its ability to set underwater or not. The most common form of lime is the lime actually that doesn't set underwater, and that's what's called non-hydraulic lime, meaning it doesn't set underwater. It sets with the air.
Yep.
It takes the carbon out of the air, the carbon dioxide out of the air to help it set. And that gives it a wonderful carbon neutral cycle, by the way, very unlike cement, which is very, very heavy, intensive carbon footprint. So lime we like. But Pakistan, southern Pakistan, has this non-hydraulic lime. It doesn't have what we call a natural hydraulic lime,
Okay.
which is something that will set underwater. So then we have to make that non-hydraulic lime work underwater. And that's where we use all the minerals in a raw clay to work with the lime. So I'm trying really hard here not to go into science.
Yeah, it's difficult, isn't it?
They're very big materials, subjects. The lime subject is huge. The
Yeah.
clay subject is huge. Putting them together is huge. And then trying to simplify all of that into something that will work for anybody on the planet, anywhere, in very simple field tests, was our challenge.
Yeah.
And myself, my colleagues, Stafford Holmes, we feel like we've actually managed to do that through a lot of illustrations from fantastic illustrations from our friend Juliet Breeze, for villagers who are illiterate.
Yep.
So, as you know, pictorially, that speaks to everybody. So it's a very simple system of field tests. So field test your soil, my soil, every soil is different. Does it have a clay content? If it does, how much clay is
Yep.
in that? And then working with lime, local lime, safely, how to work with that lime, and working out how much, through very simple field tests again, how much of that lime is required to stabilize that soil. You have to do the tests.
Yep.
You can't guess. If we're talking about a house here, you must do the tests. The tests are very, very straightforward. And then we allow those samples, the trial mix samples, to sit for 28 days.
Right.
This is where they have to cure, effectively. That's keeping them slightly damp and keeping them shaded. And then after that, we can submerge them in water. We can subject them to dry compressive strength testing, wet compressive strength testing. We can subject them to wet compressive strength testing after 2 weeks, a month, 2 months. We've got samples that are underwater now for well over 2 years, 3 years, still really strong in compressive strength.
Fantastic.
Not dissolved, absolutely fantastic. So each village would do their own tests. We had a system of working with engineers from the best NGO, I mean, most extraordinary NGO I've ever come across, wonderful, called HANDS.
Okay. How's that spelled?
HANDS, it's Health and Nutrition Development Society. They have nothing to do with disaster resilience or recovery up until the floods, when all their 30,000 villages in Sind were flooded, and they literally had to learn the whole kind of disaster, humanitarian disaster situation, but they do it very differently to the big boys. It's all about relationship with those communities.
Fantastic.
It is not top down. It's absolutely working with the communities. Big salute to HANDS.
Yeah.
And they're the people that introduced us. They got us involved to try and help work with natural, local, affordable materials for these people, so that they didn't have to do what the big boys were doing at that time, which was bringing in, concrete blocks, cement and sand renders,
Of course,
and
yeah.
mortars. They didn't want to do this. So this is really fantastic. And currently, we worked with their engineers, and then we ended up working with the engineers of different humanitarian organisations over there. Those engineers would go into villages and train local masons and villagers, and that pattern continues. The designs are disaster resilient for earthquake as well. But what we're looking at here is really exciting. The whole foundations are of lime stabilised soil. There is not a drop of concrete anywhere, of cement-based concrete anywhere. It's lime concrete. The plinth walling, the blocks, the mortars, the internal plaster where needed, all the external render coats, the subfloors, the floor screeds, finishes, and roof screed. Everything is lime stabilised soil.
Fantastic.
It's really, and this is all tested for their particular soils.
Yeah.
And women have said to me in villages, they really, really wanted their children to learn this technique because they don't want their children to have to do what they've had to do, which is to rebuild their house 3 times in 3 years. And what was really moving is to see women redecorating their houses externally with lime washes and beautiful decoration. Again, they'd stopped doing this because they'd lost faith in their houses. So this material is monsoon resilient as well. It won't wash off with the monsoons. And inshallah, it will not, it certainly won't fall down in the floods. And to date, because it's continuing, there's about 200,000 lime stabilised soil houses, as I understand it.
So is that you've trained up a certain amount of people and they've gone off and trained?
Yes, we've trained up a set of engineers for HANS, for IOM, for ACTED. They in turn go out and train masons and villagers. I was out again in December and January this year. And I tell you, I'm just so moved by their wonderful, incredible work. It's quite extraordinary. People taking such ownership and such joy in their houses that they now re-believe in. And this is all local materials. Clusters of villages, or each village has their own lime slaking and settlement tank. It's just amazing. They all know how to handle lime safely. They all know how to test the quality of it before they buy it. Then they slake it to lime putty. They know how to keep it. Women were showing me the lime settlement tanks, opening them up because they're kept under cover and the inch of water over them, and bringing out the putty and showing me the quality with great pride.
Of course,
this is super moving. This is absolutely wonderful. So that is a technology that is accessible to everybody. It's old technology. It's not new. The only things left standing that we saw way back in 2012 in whole tracts of land were the old shrines, and mosques that had been built with lime. Everything else had gone. It was really, the devastation was extraordinary. So lime has a fantastic tradition in Pakistan. And we have found samples of lime and soil, so stabilised, that are in the region of 700 years old. Outside, and Mukli, which is a huge graveyard with beautiful old architecture. We found some really old samples there. We found samples pretty much everywhere. This is very old. It's lovely to be able to call on that old vernacular. So it's not introducing or even reintroducing, it's refinding, it's rediscovery, and helping people rediscover that themselves and take ownership of their heritage.
Is there an idea of why it's sort of been forgotten, or is it?
It's called OPC. Yes, you just look around the world. It's concrete is taking it. Portland cement-based concrete is taken over, and this, as you know, has a very, very high carbon footprint, and that's why we have for many, many years tried to avoid using cement in any of our buildings. It was a real policy with Amazon Nails, who that was my first straw bale experience working with a great commitment to local natural materials and cement-free as much as possible. Portland cement has a carbon footprint of, it kicks out 1.25 tonnes of carbon emissions for 1 tonne produced. Effectively, cement factories are CO2 emission factories where cement is the byproduct. They create more emission than they do product. Whereas lime, the lime cycle, can be carbon neutral.
It's the lime cycle is carbon neutral, but not the energy that's put into...
Well, that's very interesting, because the energy, traditionally, like in Pakistan, it's what's called faggot, so it's just brushwood around. But, over here we might use coal still, we might use timber. We are currentently working, myself and Stafford are now working with a community in Portugal called Tomera. They have a technical team there, and I've been partnering them for a number of years now in something called the Blueprint Alliance. So we're committed to models of regenerative resilience for communities worldwide, and it brings together every component really of regeneration and resilience. So it's energy, water, natural buildings, etc. So one of the things Tamera has developed is this amazingly affordable and accessible solar system.
Okay.
Which we are now using. We're just going out now later this summer to design solar kilns for burning,
Really?
for burning lime at community level. So we're not talking about high tech here.
Yeah.
We're talking about building the kilns with local materials and testing them at Tamera, and also biogas. We're using the biogas system there to develop a biogas kiln. So this carbon zero cycle with lime, we really, really want to be carbon neutral, completely, which would be fantastic, and in the hands of local communities. So that's very exciting. Together with unfired clay, you're then turning non-hydraulic lime, which, as I say, is much more commonly found than hydraulics. If you need to work with water, you can turn it into that hydraulic lime just by using the minerals in the raw clay, because how they react with the lime is really, I call it magic mud. But you have to, you just simply have to find the right ratio. You have to find the right recipe for your soil, which will be different to the recipe from my soil.
Yes. Everyone wants
just
the
simple
recipe,
field
don't they?
tests, because you can put too much lime in and it won't be stabilized. Too little lime, it won't be stabilized. You just have to modify if you need to. You just need to find that right proportion of lime, and it's usually very, very low.
Is that information available somewhere?
Well, we're just about to produce a book.
Oh, that's handy.
And you didn't know that.
I
did you?
genuinely
You
didn't
genuinely
know.
didn't know that. I didn't say a word about it. Yeah, it's coming out with practical action within the next couple of months.
Oh, fantastic.
Yeah. So it's all we want it to be. We want it to be out there as accessible as possible. Because we truly believe we've seen the impact of this incredibly simple technology. Well, it's not simple. Do you know what I mean? We
Sort
can
of
make it.
It's very
workable.
clever, but
you
very
can
simple.
make
isn't
it work. People. I mean, we are 200,000 houses in Pakistan. These are villagers who definitely do not speak English, most of whom are illiterate, who have taken ownership of this material and this system. We're talking entrepreneurs here. These are people who are going on and building. They're making blocks, lime stabilized blocks, and selling them onwards.
Right.
Because burnt brick comes in two classes in Pakistan: Class A, which is 7 rupees a brick, and Class B, which is slightly inferior quality, and it's 6 rupees a brick. Now you put a 6 rupee burnt brick, mind, right? It's fired in a bucket of water, and after 3 days it will start slowly, but it will start to dissolve, and you can see this happen. Obviously, you put a mud brick, even though it's really strong in dry compressive strength, into a bucket of water, that's going to dissolve probably within half an hour. You put a lime stabilized soil in a bucket of water, that community can watch that for a month, 2 months, and go, okay, I'm having one of those. So really, this is really, it offers a lot of potential and a lot of empowerment.
Yeah.
And in Nepal, we've been putting that technology together with the earthquake resilience that straw bale building, straw offers. So I've been working with, Straw Builder's been working with Builders Without Borders last year in Nepal to build Nepal's first straw bale house.
Okay.
Which is it's a beautiful community. It's called the Kevin Rowan Memorial Eco Foundation, just south of Kathmandu.
Okay.
Again, anybody going to Nepal, please go visit them. They're just extraordinary community with a lot of different earth building examples, and they've just been building 12 houses for earthquake resilience for those affected villages from the 2015 earthquake.
Right.
Superb community. Go visit them, and that's where the first straw bale house is. So that's bringing the earthquake resilience. We all know how wonderful that is. Those of you who don't, have a look at the PAC-SPAB shake test for straw bale, which Darcy Donovan conducted in the States, I think in 2014.
I'll put a link to that on
It's
the blog.
absolutely wonderful, and it still makes the hairs on the back of my neck stand up. You know, it just shows categorically that how straw performs in a real house in a very strong earthquake situation. You saw this last evening.
It's twice the strength of the biggest.
It was
earthquake,
a very,
was it?
very fantastic. It was a very strong test. I think gravitational forces beyond those that of the strongest earthquake at that time.
Yeah.
Even to date, in fact, and it's just so moving. the worst that happened is the plaster cracks.
Yeah.
Nothing fell down. And as we know, even if straw were to fall down, it's a lightweight material. It's not going to kill anybody. It's very, very moving. So bringing that technology to a seismic area together with the monsoon resilient lime stabilized soil, local soil renders, fantastic. And if you're likely to be in any running water, flood water, then for sure one can use the flood resilient lime stabilized soil.
And is straw available
for all the other elements? In Nepal, absolutely. Rice is a staple.
Right.
There's a lot of different straw available. Obviously, you've got a different terrain. You've got a lot of terracing. It's usually lower down in the terraces where straw is available. In fact, people were selling straw around Kathmandu for mushroom growing. There is a question mark around, well, if people use straw, unlike in some parts of the world where it's burnt still, they use straw for cattle. It's a one-off investment of using your straw to build an earthquake-resilient building, and thereafter, you can return to feeding your cattle. Who knows where this will take off? We're still trying with Martin Hammer of Builders Without Borders to get the material approved by the Nepali government as an approved material and methodology for earthquake resilience, as well as lime stabilized soil. So working with different organizations in Nepal to have lime stabilized soil accepted by the government, again as an approved material and method. Having said that, it is being used. UNESCO World Heritage have just approved lime stabilized soil for temple rebuilding in Kathmandu, which is really exciting. And we've been also working with with bodies in Kathmandu who work with lime already in terms of proper lime use for temple repair, because there's been so much devastation of temples, and there's been a decree to use lime where earth might have been used as mortars. And the lime knowledge by everybody having to use lime without any real kind of training has sadly resulted in some improper use, which eventually may really impact the faith in lime. So that's we've been trying to give a hand there.
Well, how can people find out more? What are the ways? Your website. What are the sort of things that people can drill down into and get more info?
Yeah, sure. Okay, so our website definitely needs updating.
Don't they all?
Don't they all? So in terms of the panels, definitely one can go to Ecococoon.
Yep.
And there's a whole translation in English.
Yep.
There's a little bit on our website, which is strawbuild.org. And for the lime stabilized soil, as I say, this book will be coming out, and I'm really hoping to put something on our website about this, because it is, as I say, magic mud. The whole thing is magic. The fusion of these materials together with straw for earthquake resilience, and then the lime stabilized soil for flood and monsoon resilience. To me, you've got a great disaster resilient methodology there, which is all local, natural, affordable materials. Absolutely, it's just so exciting. To have that in the hands of people who do not then have to rely on outside aid. Yeah. The cement industry, etc. So this is, although radical, it's that link with our heritage, which I love. And it's just understanding materials, understanding how they perform, and actually getting the best performance and durability out of them. It's a very, very exciting time to be involved in natural building and play a part in what we all need to be much more aware of, is the climate catastrophe, which is on our doorstep.
Yes,
right now.
It's already happening.
We can do something about this. We can.
Excellent. Well, thank you so much for coming in and chatting to me on this slightly windy but glorious morning.
Very glorious. Thanks, Jeffrey. It's lovely to see what you're all up to here, and you're all part of that movement of solutions.
We're doing what we can, I guess. And do please come back and test our soil and tell us how much lime we should put in it.
Let's do it. No, I won't tell you anything. You'll do it yourselves. We'll do it together.
Excellent.
Fantastic. Thanks very much. I look forward to it.
great. Welcome back.
Yeah, that was good, wasn't it?
I'm not allowed to say yes.
Well, I thought it was really interesting. It's always great catching up with Bea. I particularly liked visiting her site that's near when we went there to see the Ecococoon. I've seen the panels in kind of an eco build or trade shows, and I've read a bit about them, but I've never actually kind of seen anything made with them. So being able to put that whole, the how fast it went together compared to seeing the structure, it's incredibly impressive.
Yeah, and flat as well.
Yeah.
I think the amount of time saved isn't just in the building, it's in the plastering as well. And then Bea's had a fascinating career, hasn't she?
Absolutely, yeah. Really interesting. Going through mechanical engineering, lawyering, essentially, advocating.
Yeah.
Fab. I thought it was really interesting, the fact that she'd got no formal training as well. I think that's something I hear quite often.
Well, it's not like there's a lot of opportunities
No.
for training in a natural building. In fact, I know she does have one qualification, which I think is the same one as you, which is rammed earth.
Right. Yeah.
I have no formal qualifications. I've got apprenticeships and
Yeah, sure.
but nothing that's like a little bit of paper.
Yeah.
Yeah, I've got nothing to add to this conversation. I am absolutely shattered.
Yeah. Well, I think she said everything, didn't she?
Great. Well, thank you, Joseph.
Thank you.
Thank you, listeners. Do drop us any comments or ideas for people to talk to.
Yep.
And we will be back next month with a fantastic, probably my favourite interviews so far.
Exciting times.
Yeah.
And that's not a slight on any of the previous ones. We just keep ramping it up.
Yeah, it's always getting better.
Yeah, and do check the sleeve notes for this podcast for lots of exciting links to the stuff that we've been talking about.
Oh, that means I have to do sleeve notes.
Well, you already said you were going to do it in Bea's bit.
That's fine. No, that's fine. I like it. Good. Well, yes. Until next time.
Bye.
Goodbye.